Hello, my name is Ethan Negret, and this is for the extra credit on the final exam, where I'm going to be teaching a class on files. So we have the mind map open here, libraries, and then so the library you're going to want to include, which will go down here, is FStream. So, mm, And what this does is this just allows all the file functions to be included onto your compiler so you could write programs with. And here you could see all of them right here. So first you have your IF streams and your OF streams. IF streams, it's an acronym and it stands for input file stream. And you could think of these streams as bridges between your file and your main CPP right here, where you write your programs. And what they do is they just kind of talk to each other in a way, and they share information between main.cpp and whatever file you're using, right? So on Zybooks and on Ed, I wasn't able to get the correct the function for making the file to work. So there's going to be some gaps here, but you could imagine and like fill in the blanks. So starting off with IF stream, these streams also function similarly to character inputs or CIN and character outputs or cout and away, and you'll see right now. So how to write this, you could see the definition here on the mind map. You pretty much declare it first like a variable. So you go if stream and you give it a name. So usually a common name would be infs, and that just means input file stream, and semicolon to end it. And now it's declared. So now you built this stream. And what you want to do to open up your file, you do the stream name and this function here dot open. And so what dot open does is it opens, you could think of it as like it opens the file it opens the file that you're working on, right? So you'll have a file, for example, take example.txt, right? So we'll do nfs, which we have down here, dot open, parentheses, example, or team, soccer team, we'll go soccer team dot txt, and make sure, like how I didn't, make sure you put this inside of quotation marks, and then you close the parentheses, and now this opens up your file, right? Sometimes if you're writing a program and you want the user to input which file you want to open, say if you have multiple files, then pretty much what you do is you make a string, name it, we'll go file name, just so it's easy to read and understand. And down here, instead of writing the file name, this is just a string, by the way. This is just a string that you're writing. So you could just put the whatever string variable you set file name, and make sure you have user input written too. So the user can actually input a file name in here, right? And so now that it's open, it's always good practice to make sure it's open with .is open right here. And you could go ahead and read that, but in a nutshell, what this function does is it just makes sure that the file opened correctly. And you can check if it opened correctly by one if statement. You write if the stream name in fs, or whatever you named it, .is underscore open file name, right? Make sure you do an exclamation mark, and that just means that if it returns false, or if it returns false, then it'll go through this, right? This thing. I believe. I believe you don't need the file name here. Let me figure it out. Then we'll do a quick cut. Okay. I figured it out. You do not need the um you do not need the file name and the dot is open. So how that is going to look as soon as I get this situated is you're going to write your if statement. If the stream name dot is underscore open, parentheses, you close that out, you close the if statement, um, right? And make sure that this is important. You include the exclamation mark. And that just means that if this statement right here, if this condition right here returns false, then the computer will run through that branch. And so what you do to fill in the meat of this if statement, you'd go count. This is if it doesn't open, right? So, or if, yeah, if it's false, if it returns false or doesn't open, you do count file could not be open or found slash found to, because it can mean that it wasn't found, and L, and then you do return one. And what return one does is you could see how you notice how you have return zero at the bottom of your program right here at the bottom of main. Return zero just means that if it allows the program to exit properly or to stop itself properly if there are no errors and if everything is written correctly, right? So if all your code is good and then you run it and it stops, you'll get a little X or a little message saying your program exited with 0 errors or something like that. Then that's thanks to this return zero. And return one means that if this is true or after it runs this, it just shuts down the program. It like turns it off. You could think of it as like a little switch. So if this is true, it's going to output this and turn itself off so it doesn't break. And this is helpful. So like if you have loops involved and then something goes wrong and then it sets off an infinite loop and it breaks it just breaks everything and it's super annoying to fix. This kind of stops that. And this is like think of this as like writing your own safety net just in case, right? So we come down here, close days, right? Whatever you are going to do, it's very important that you use dot close at the end. You open something, you close something. Always think about it like that. And if it helps, write it in the beginning before we write all this stuff here. So we have dot open. Make sure we do dot close too. What dot close does is you could read it here on the mind map. It just closes the file when you're done with the stream. Yeah, it just closes the file. And that's important. So streams take up memory. You don't want to always be taking up memory, right? So you do NFS, name of your stream, or whatever it might be. And that's all. So now writing the meat, the rest of this program, let's say we have a soccer team, right? And we want to read all the information within that soccer team. What we're going to do is we are going to write a while loop, right? So we could read all this information. And the condition of our while loop is while NFS is false, right? Dot fail and while NFS is false dot EOF. So when you're working with files, the way that computers store things is a bit. A bit is you know what a bit is. It's just it's the computer's language of turning words that we associate meaning with into its own language of ones and zeros and binary that the computer understands. Um, when you're writing a file, sometimes you have what you call a corrupted bit. And that isn't good because if you run into a corrupted bit while you're reading through a file, it could crash the whole system of whatever you're on, and break your program completely. So it's important that you make this little safety net here for yourself while dot fails so you could turn off the loop. And what .eof does is when it reaches the end of the stream, .eof is going to return true, right? So we want to have the loop running when it's false, hence this thing. Exactly. So we want to take away the exclamation mark. So when .eof returns true, this means that you reach the end of the file. That's what that function means. Got to do that, right? And so the whole time when you're in the middle or at the beginning, it's always going to return false because you're not at the end. And how to read the information, right? Think of think of the think of the file or of the NFS as CIM, like how we talked about before, right? So it's written, formatted the exact same way when you write it. So you're going to do your stream name, NFS. When you're writing things or moving things over to CPP, you do these two little arrows right here, right? Exactly how you write a CIN. And you just do whatever variable. I've got to write. So we'll go here, save to file on a soccer team, right? String name, player names, and int team jersey number, right? So you do int, or I'm sorry, excuse me, player names here in FS, jersey numbers. Okay. And this is just going to run an infinite and read until it either A, runs into a corrupt bit, or B, reaches the end of the file. And why do we choose a while loop over a for loop? This is very important. Think of the differences of when to use a for loop or when to use a while loop. You use a for loop when you know how many times you want to iterate, right? And you use a while loop when you don't know how many times you get iterate. And this is important because when, let's say you're running a file, you don't know how big that file is going to be. So you want to iterate as many times as you can so you could get all the information until you reach the end, right? And so while loops run infinitely or iterate an infinite amount of times until a specific condition that you write is met, which is why we use a while loop over a for loop, because we don't know how big a file is going to be and we don't know how many times we should iterate. Hence why we use the while loop. And once we have this information, we could output it. We could do all sorts of stuff in CPP if we want to do, if it was like scores or wins to losses, we could then output this information. If it was wins to losses, right, we could do count wins. If it was, imagine this is a variable, uh, count losses, right? We could do all sorts of stuff. But now what this while loop ensures is that we have whatever is on the file over onto main. And that's really if streams. Now, OF streams or of streams are a little different. So we'll go ahead and comment this all out. Da-da. So say we want to write something, right? We'll do, give us some space here. Exact same process, right? We define our OF stream, give it a name. Usually people call it OF. What was NFS? Forgetting what the usual term is that my professor calls it. Call it OutFS, right? Or that works too. OFS, right? And so when we have that defined, we open whatever file we're going to open, right? So we'll have a string file name here just so user can input stuff. Again, here we are. And then we need an open function. So we do OFS, name of our stream, dot open, file name, right? Then we make our safety net. It's always important that we make our safety net, just like the last time up here, just in case it's not open or it can't be found. Should we add our return one? Close it, right? And so what OF streams do is it writes information that, say, a user is going to put in, or if you have from another file onto the file that you're talking about, onto file name here. Whatever you store in file name, O stream is going to write information onto that file that's assigned to that variable. Right now, how do you do that? So what you're going to do is you define what you're going to write. So let's say if we're wanting to add players on a soccer team again, we're going to do string player name and int player number, right? And we have, give me a minute to think. And so how this is going to work, writing stuff on there, we don't use a while loop. It's actually easier because we're not reading, right? Well, I suppose we could. I suppose we could. So we'll write character inputs for both player name and player number, right? And then we will make a while loop and want to know what we need? We need a condition to turn this off. So out, quit, and we do bool quit. Sign that to true. Or assign that to false, actually. So while I'm doing this, I'm just making sure that the user can turn off the while loop and so it doesn't become infinite, right? And so if quit is not equal, there's equal to Q, we'll say. Be anything really, right? We'll assign quit true. Okay. Now that we made that for ourselves, we could go back to our while loop, and while quit is false, right? We go, how to write this? This is important. We go OFS, the the same arrows we use for count, right? But with OFS, and then we do player name, OFS again to write the other thing, player name, and actually \T, which is going to make a tab so everything's neat in there, right? And you could also output a name, but for the sake of simplicity, we will we will not, right? And for the sake of time as well. OFS, and then we have what was that? What was that player number? Yep. And Dell. And then ask the user for another player name, another player number. Oops. You want to know what I didn't do? I didn't make a variable for q. So we'll do char with capital Q. This if statement should be inside of our loop. That is my bad. Get some organization in here, right? We'll move this count down. There we go. It should also be in the loop, shouldn't it? Excuse me for working out bugs. This is a very rudimentary loop, but for the sake of example, right? For the sake of the focus of where our mind should be. This is the reason. right? Player number and L, just for user friendliness. Or one to continue. Then we need to write that if statement again because I accidentally got rid of it. If quit is equal to Q, Q. What is that there? There we go. And here we have our program. And if we try to run it right now, it's going to display an error message, but you could imagine if we run it, the program is going to keep asking us for a player name and a player number until we answer Q. And when it gets that player name, it's going to write that thanks to these two lines right here into our file. And that is everything about files. It's a very short unit, and I encourage you all to read the mind map, take your notes, and do the Zybooks too, because they are very helpful. Anyways, have a good day. Goodbye. Thank you.